For a long time, distance meant safety. Move far enough behind the front line, and the danger dropped. FPV drones couldn't reach you. Artillery had limits. So trucks, supplies, radars, and command posts could operate deeper in the rear. But that safe zone is getting smaller, because now a small Ukrainian drone can fly deep behind the front. Its name is Hornet, and according to publicly reported figures, its reach can approach 150 kilometers. But that number isn't the most interesting part. The real question is this: how does a relatively small drone fly that far, find its way, and still threaten a target at the end? To understand Hornet, you first need to understand the gap it was built to fill. Close to the front, small FPV drones are everywhere. Far beyond it, larger, long-range drones can fly hundreds, sometimes thousands of kilometers. But what about the space between? 50 kilometers, 100, even farther. This is where the battlefield starts to look very different. Supply trucks move through this zone. Equipment is transferred. Radar systems change positions. Command and support units operate. For years, moving deeper into the rear gave them more protection. Now, that assumption is being challenged. Because drones like Hornet are pushing the threat farther back. Look at Hornet and you might expect something much bigger. You won't find it. This is a small fixed-wing aircraft. Public reports describe a body roughly 1.4 meters long. Its wings stretch about 2.2 meters. Total weight? Around 15 kilograms. And it can reportedly carry a payload of roughly 5 kilograms. Compared with a cruise missile, that sounds tiny. But Hornet isn't trying to be a cruise missile. That's the point. It's smaller, simpler, and much cheaper. Reports put its cruising speed at roughly 100 to 120 kilometers per hour. It doesn't even need a runway. A compact launcher throws it into the air. Its rear propeller starts pushing it forward. And then, the long flight begins. Now comes the difficult part. Flying a long distance is one thing. Knowing where you are after flying that distance is another. Satellite navigation can help, but modern battlefields are full of electronic warfare. Signals can be disrupted. Navigation can become unreliable. So relying on just one source of information can be a problem. And this is where Hornet gets interesting. Reports describing recovered examples point to satellite navigation combined with an optical inertial navigation system. Cameras reportedly look forward and down toward the terrain. That gives the aircraft another source of information about its movement and position. Does that make Hornet impossible to stop? No, not even close. But it shows something important. Drone navigation is becoming harder to defeat with a single trick. Here's where people often misunderstand drones like Hornet. The most important target doesn't always have to be a tank or a missile launcher. Sometimes, it's just a truck. That sounds less dramatic until you remember what that truck is carrying. Fuel, ammunition, equipment, maybe spare parts. Because armies don't move without logistics. Every tank needs fuel. Every artillery unit needs ammunition. Every damaged vehicle needs parts. And all of that has to travel somewhere. Now imagine those supply vehicles having to stay farther and farther away from the front. Routes get longer. Deliveries get slower. Everything becomes harder. That's why a drone reaching deep into the rear can matter far beyond the size of its warhead. But there's an obvious question. If the target matters, why not just use a missile? The answer may be the most important part of this story. Money. A sophisticated missile can be extremely expensive. A small drone can cost a fraction of that. And suddenly the calculation changes. You don't necessarily need a $1 million weapon to threaten a truck, or a radar, or another support vehicle. You need something cheap enough to send once, then again, then again. But don't confuse cheap with unstoppable. Hornet is relatively slow. Air defenses can engage drones. Electronic warfare can interfere with them. Weather matters. Mechanical failures happen. Navigation can fail. There is no magic weapon here. And that's why Hornet matters. Not because it's the biggest drone, it isn't. Not because it carries the largest payload, it doesn't. And not because 150 kilometers is some impossible distance, it isn't. Hornet matters because of where it fits. FPV drones changed what happens close to the front. Long-range drones brought targets hundreds of kilometers away into the fight. Now drones like Hornet are filling the space between them. And that changes the map. A truck can be far behind the front and still be at risk. A radar can move to a new position and still be within reach. A logistics route can look safe until a small aircraft appears overhead. Hornet is just one drone. Its capabilities will keep changing. Other systems will follow. But the bigger trend is already becoming clear. The battlefield isn't just spreading sideways, it's getting deeper. And the old idea that distance automatically means safety? That idea is disappearing fast. Follow GeoMind for more military technology explained.